Well, hello everyone. My name is Robert, and today we'll be talking a little bit about Ethereum, which is one of these blockchains. Last time we talked about Bitcoin, and we did an introduction for Bitcoin, and we talked about what were the social and political and technological and business histories that led to something like Bitcoin to be created. And in fact, if we're going to start talking about another blockchain, we should really start talking about Bitcoin first and build on top of that again. So we'll do a little bit of review of what's going on with Bitcoin, and then we'll go from there. First of all, what is Ethereum? Well, it's kind of like Bitcoin, but we have a virtual machine on top of this blockchain. So just as a brief review, how does a single Bitcoin transaction get approved? The reason why we need to talk about this is that Ethereum has two different types of transactions. The first is very similar to how Bitcoin's transactions go through, and then the second is a little bit different. So we'll talk about that later. So what happens when someone wants to present a transaction and execute a transaction on a blockchain? Well, first of all, someone who owns some Bitcoin and has a public address will go and propose a transaction, indicating that the withdrawal address is their own address and the deposit address is some third-party counterparty. And they'll sign for that transaction with their private key. Now, you'll remember from last time that every wallet has both a public and private key. This is called asymmetric cryptography. And it's what allows ownership over that Bitcoin. For the public address, everyone can see how much Bitcoin a given wallet has and their full transaction history, but only the person with the private key can sign for that transaction for it to go and be settled. So what happens after that? Well, turns out what this private key situation means is that that private key is effectively your signature for sending that transaction. And what a Bitcoin really is, that question comes up a lot. What is Bitcoin? Well, maybe it's a number on a ledger, but more technically accurate would be to say it's a electronic coin that is a chain of digital signatures. And in fact, that comes right from the Bitcoin white paper. So what happens after the transaction is proposed? Well, there are thousands of computers all over the world that are serving as something called a node. And these nodes are maintaining copies of this ledger, which has all of the previous transactions for Bitcoin. And they're also maintaining copies of these newly proposed transactions. And those sort of newly proposed transactions, there's actually no one central place where all those transactions go, but loosely it's referred to as a mempool. And what happens after that is that some of those nodes conduct a process called mining. Now, we talked a little bit about this last time, so I want to keep it a little brief, but with miners, what they're doing is they're running a software such that they are settling the transactions. And so what does that entail? And what does that mean? Why are there miners and nodes? Well, every miner is a node. So every miner will keep a copy of the most recent version of the blockchain, but not all nodes are miners. So you can keep a copy of the blockchain and not do any mining. And we'll talk about what that means, why that's possible, and what's so important about that in a little bit. So what does a miner do? Well, they create a bit of memory, and then this is called a block from blockchain. They create a bit of memory. They store their transactions in this memory. They collect them. They have multiple different transactions from multiple different parties going to multiple different parties in the same block. It's effectively numbered, and it references the previous block in that all of the previous history of the blockchain is through a process called hashing, which we talked about a little bit last time. all of this previous blocks are the input that makes this block have a unique code, so to say, or a unique block ID. So each block references a previous block, so that's how we get chronology. And what the miners are going to do, they're going to do a few things. So first of all, they're going to check the signatures of all of these transactions to make sure that this Bitcoin that's about to be spent and settled has not been signed for before. So we talked a little bit about last time how that solves the double spend problem, because you can never spend the same Bitcoin twice. And this is a major issue with the modern banking system. That's the first issue. And then the second issue is the miner is going to do something called proof of work, and it's going to solve for a nonce. So why do we have this proof of work, and why are we solving for this nonce? What is this nonce thing? Well, a nonce is a cryptographic puzzle, and what that means is that it's actually a very simple piece of technology, but what it requires the computer to do is guess at the solution to that puzzle over and over again until it finds a solution. Why do we want the computer to do that? Well, because the computer is then spending electricity, and by spending electricity, they're putting in work to prove that they are faithful actors on the network. Because they have to spend computing power to solve the nonce, they have to spend electricity, which costs the miner money. And so we'll talk in a little bit about what the miner's reward is, but effectively that spend is a deterrent. It's a buy-in to make sure that all of these miners are operating in good faith once they get their reward. It also means that because it's difficult to mine these blocks, and actually you can look up hash rate or difficulty rate history, it means that it's much easier to just add another block than it is to reverse 5 blocks, because you have to do the electricity spend for all those previous blocks. So what that means is Bitcoin effectively is additive and immutable, because the miners don't want to reverse transactions. And if you're in a world where there are thousands of different computers and there's no one central authority like your bank to go to reverse a transaction, well, you don't want all these transactions in a given block to be reversed, or even the risk of it, because then your asset would effectively be worth nothing. If you sent a payment yesterday to your friend for $100 to pay for, I don't know, your Netflix subscription, okay, $100, okay, a year's worth of Netflix subscription, and then today, that transaction was no longer on your bank statement, there's, it doesn't help you very much if there's no faith that the transaction will be there tomorrow. So that's why we have the mining process. That's why we require them to spend electricity, because it's hard. It's hard to do, and it's harder to do it for 5 blocks than it is just for adding 1, for example, and 5 is just an arbitrary number. So what does this all mean? Well, once the solution to that problem, the proof of work, is done, it is presented to the rest of the network. Let's get this, okay? I actually want to go back. So it's presented to the rest of the network. The nodes include this new block in their copy of the blockchain, and then all of the other miners signal their approval of that block by building the next block on top of it. So you can imagine that there's actually no kind of hard voting system. For example, like a miner says, yes, this is legit. All that really happens is that the other miners see that new block and say, okay, interesting, let's check the solution to that nonce. Let's make sure the proof of work was legitimate. Let's check all that transaction history and check to make sure that that nothing was double spent, and that the signature was not spent on previous Bitcoin. And then those miners get to work on adding another block. So that's really cool. So why is this important? Why is this important? Well, these block miners get paid a miner's reward. And the reason why I just want to bring this up is because earlier this week there was a something that happened that got a lot of media attention, and it's called the halvening, so to say. But this happens actually every 210,000 blocks, where the miner's reward for Bitcoin actually cuts in half. So why is this important? Well, this goes back to what we talked about last time with the history of why we have Bitcoin, but effectively the early creators were cypherpunks and libertarians, and they were concerned with how central banks go about printing money, so they wanted to create what they thought would usher in a deflationary asset, in that the newly minted Bitcoin every cycle is being cut in half. So every 210,000 blocks, the miner's reward cuts in half, which means that there's less and less new Bitcoin being pushed into the economy, into the money supply every 210,000 blocks. And what that effectively means is that eventually we're going to have a hard cap of 21 million Bitcoin. So that's just an interesting feature. And I thought I'd explain that because I saw a lot of, content being put out there that may or may not have been totally accurate, or may have been misunderstood but presented anyway. And then this is just one more thing I want to talk about, which is forking. So we talked about earlier how miners are just building on the most recent block. Well, you could have miners that are actually building on what they think is the most recent block, but may not actually necessarily be the most recent block. These are called forks, effectively. And the way Bitcoin fixes this is that the longest chain, or the longest number of blocks, will always be sought out by miners to have their, to build the next block. So, that's how we get around the solution of we have all these computers that may be building in different directions. The shorter chains eventually get removed because all the miners are programmed to just build on what is considered to be the longest chain that it could find at all times. But this forking idea actually has resulted in the creation of new Bitcoins, or new blockchains, excuse me. So you could think of things like Bitcoin Cash, which is a fork of the Bitcoin blockchain. And you can actually have, effectively, the original blockchain with its original miners following the old rules, and then a new blockchain, which is the same as the old blockchain all the way up to a certain block, and then implements new rules at some fork. And then certain miners can decide to start effectively building on that new blockchain if they want to. So that's how that sort of forking process works. So what is Ethereum, and why are we talking about Bitcoin with respect to Ethereum? Well, blockchain's a really interesting technology in general. Bill Tai, who's an early blockchain adopter, but his Silicon Valley experience goes all the way back to the semiconductor world. He was, I think, employee #1 at the Taiwan semiconductor manufacturing plant, or he has the identification card or something. But he says that blockchain is to value what the IP system for exchanging information over the internet is for information. So we're effectively entering a fourth stage of computing technologies, and you're going to see exactly why that statement is so resonant with people in just a moment. And then Joe Lubin, who founded Consensus and co-created Ethereum, sees Ethereum as a way to scale decentralization as an organizing principle. So what is this Ethereum thing? Well, it's kind of like Bitcoin, except on top of it, we have this virtual machine. And this virtual machine allows for the development and execution of something called a smart contract. So what is a smart contract? What's a virtual machine? What is all this? First of all, smart contracts are not new phenomena. Ethereum was founded in and launched 2015, 2016 by Vitalik Buterin and the great team over at Ethereum. But smart contracts were not a new concept. Smart contracts had actually been around since the early 1990s when Nick Szabo first proposed them. And effectively what they are is they're a contract, but instead of being executed by a lawyer or a court or business people, it's executed by code. So now you can have a computer or the parameters of a smart contract on a computer. The parameters could be, we have some agreement, but there needs to be some input data to execute that agreement. So, there's a lot of good examples that we'll talk about in a moment, but that's effectively the thought about what a smart contract can do. So what is Ethereum? Kind of like Bitcoin, we use proof of work, but we've added this virtual machine. It can automate transactions and it could automate business logic. And it could go as far as, disintermediating bureaucracy, and you could use smart contracts for a lot of the functions that, we hire business people to do currently. So why is it called Web3, and why was it called in the early days the world computer? So that's what makes Ethereum so interesting from a technology standpoint. If you think about the computers you have now, you can think about, sort of Bitcoin as a ledger or as a calculator. It does a very basic function use case really, really well. It's commerce. And that's said endearingly because, sending transactions across borders with no intermediary is a very, very difficult feat to have pulled off while solving for double spend and the Byzantine fault tolerant, the Byzantine generals problem, which makes it Byzantine fault tolerant. It's a remarkable feat. And, we talked about the Byzantine fault tolerance issue last time, but why do we care about Ethereum? Well, it takes that, effectively what Bitcoin is to a calculator or a ledger, Ethereum is to a punch card or a computer. And the reason for that is that by having a virtual machine, Ethereum has something called state. So what does that mean? What is this idea of state? Why do we care about it? Well, in computing, a computer is considered to have state if it can remember things. So your Mac that you're watching this on right now, it has state. It's gonna, if you download this video, it will store it someplace on your machine and you'll be able to access it later. The process by which the file of this video is stored on your computer is effectively a change of a state of the computer. And accessing the file, you're accessing the state of the computer. So what does that mean for us? Well, it means two things. Well, actually it means one thing, but it means we have two different types of transactions for Ethereum. We have our transactions that are similar to how we did Bitcoin transactions. These are called plain value transactions by the Ethereum Foundation. So same way the ledger works, you have, you think of the same type of proof of work strategy to get a transaction through to the blockchain. And then you have a virtual machine which has state. And why does it have state? It's because it needs to remember the smart contracts that are coming in and the changes that all these smart contracts have made to the associated wallets by which that smart contract has made a transaction or effectively made a transaction happen. So the virtual machine is a different type of transaction. And the reason why we consider it to be the world computer is that that state is maintained by thousands of different computers all over the world, in the same way Bitcoin transactions are maintained. So you have decentralized the computer. It's no longer one machine that is just storing state. It's a shared state that's being stored by multiple different computers and updated by multiple different computers. And that's a fascinating evolution of computing. You can imagine we went from the vacuum tube computer to simple calculators to the desktop, then the laptop, and I missed one. Giant servers. That happened before the desktop and the laptop. But the desktop to the laptop to then we have cloud computing where centralized servers can store a lot of different computing information. Now we have decentralized computing, and this is really fascinating. But it does give us some issues with respect to how we trace those transactions. But nonetheless, it gives us a lot of very interesting opportunities. So now we have some design sort of considerations that we might want to talk about when comparing Bitcoin or Ethereum, and I want to just go through this so that we have a good understanding. So Bitcoin and Ethereum, block size. So the Ethereum block size is significantly smaller, and the average block creation time is significantly faster than it is for Bitcoin on average. Why is that? Well, we talked about earlier how these smart contracts enable business logic. And if you're doing business, you're going to want transactions to be settled very quickly, especially if that business is automated. So, it would make sense to have much more quick. Very quick, yeah, let's go with that. My English is not where it needs to be right now. It would make sense to have very quick settlement of these blocks relative to if we were just doing transactions. Circulating supply. So Bitcoin, again, you can calculate where the half-life is bringing the maximum supply in 100 years. Well, there will only ever be 21 million Bitcoin. With Ethereum, it's technically not been decided yet, and miners, earn a certain amount of Ethereum per block. But what's interesting is that with updates like Constantinople, which is the name of a software update that's going out for Ethereum, we're seeing some of these block rewards being reduced. And this is because, while Ethereum didn't sort of hard code from the beginning what its hard cap maximum supply would be, it shows the contributors to the project are still interested in the idea of scarcity for its asset. So effectively what this is, some good analogs for the Bitcoin and Ethereum assets are Bitcoin is kind of like gold in that it's deflationary and it's being viewed as a hedge against some inflationary assets, and that's not financial advice. But and Ethereum can be considered to be oil. And why is it considered to be oil? Well, it's because Ethereum is used as the fuel to enable smart contracts being settled. So that's what makes it really, really interesting. And I just want to see where my slides are here. Yeah. Okay. So what can we do with these smart contracts? Well, some fascinating things can be done, some fascinating use cases. First of all, they make ownership undisputed. So you can actually automate the clearing and settlement process. So two people can agree to sell a house. They agree on the price. They agree on the contracts. But as many of you know, in real estate, there's a lot of files and signatures and paperwork that needs to be done. So the smart contract can be designed in such a way where the purchaser and seller has agreed to what they want to sell or purchase the house for, what the transaction value is, and then they can put it in a smart contract which will receive the appropriate data, like all that other paperwork that needs to be signed. And once that smart contract receives that, that paperwork, it effectively executes the contract. So that's a really, really interesting use case and an example of what you can do with smart contracts. What else can you do with smart contracts? Well, it's enabling a whole bunch of different types of decentralized applications. So what does that mean? Well, really it means two things. So first of all, there's a lot of use cases for Ethereum that can't be done on Bitcoin. And that's all thanks to these smart contracts. Some interesting examples, and one that blew up is this idea of the crypto kitty. You know, smart contracts have made something called a token possible. So if you have, for example, you have the Ethereum asset, smart contracts can actually create new assets. And this is through a phenomenon called the initial coin offering. I actually don't want to speak about that today. Maybe we'll do another session on that. But the situation is such that you can create assets that are not only fungible but also non-fungible. So in our last session, we talked about how Bitcoin is fungible or non-fungible. The answer is it's very fungible. You could cut Bitcoins in half, break them down into their decimal components. One Bitcoin is always worth a Bitcoin, etc. With the non-fungible tokens that you can create on Ethereum, you can actually have unique assets that are part of the same family. So this is, think of them as art developed by the same artist. So, you know, in this example with CryptoKitties, there's actually thousands of these unique kittens that are represented by these non-fungible tokens on the blockchain, and you can purchase them. You can exchange Ether for these non-fungible tokens that are totally unique. You could think of it as a digital, let's go with Pokemon card. The only difference is the Pokemon card can never be printed a second time. They're all totally unique, and they're digital. So, you know, that's what makes it a really interesting use case. Initial coin offerings are a very, very popular use case. I really don't want to get into it. This visualizations from a company called Elementus, which does an amazing job with blockchain sort of data analysis. I encourage you guys all to go check them out, but just know that an initial coin offering, you know, a lot of companies got involved with this. Some of them are considered securities. In fact, probably most of them are, depending on how they're marketed, you know, and that's not legal advice, but basically they're the same thing as this non-fungible token, except they're fungible. So it's almost like printing or creating, you know, a new type of cryptocurrency, except it's on the Ethereum blockchain and you can exchange Ethereum for it. Cool. So moving forward, what's possible with all this? What does this mean for these types of technologies? What makes it so exciting? Well, you have the long list of Ethereum use cases, which I would encourage everyone to go check out. And I'm realizing I'm missing a slide. There's one thing I do want to talk about, but we'll come back to it later. You know, those smart contracts can actually enable a whole plethora of different use cases. So you have things like title records that can be stored using smart contracts. You have digital rights. You can actually encode voting rights to individual wallets on Ethereum using a smart contract. So that guarantees that a given individual can have their rights permanently forever. You can have tokens that represent equity. So you can think, for example, you know, the way sort of businesses operate now, you have a little black book where you maintain all the stock ownership in that business. And, it takes a while to settle a stock transfer, for example. And sometimes there's middlemen that you have to pay. And there's paperwork that needs to be signed. In the case of a smart contract that guarantees equity, well, you can have this token reflect stock in a company, and then it provides liquidity to the owner. So the owner can, the owner can effectively be able to transfer that freely. And there's some great companies. I think the name of the firm is called Nth Round Capital from here in Philadelphia, but there's some great companies that are doing that for sort of internal stock transfer agreements for companies that want to provide a more liquid method by which their company stakeholders who own stock can easily transfer to other company stakeholders that are already in the company that want to transfer that stock or do some type of internal transaction. So the opportunities are endless. Anywhere you have a transaction, you could think of a smart contract use case. And that's what makes Ethereum so powerful is beyond it being distributed computing, in that it is a system with state and has memory. You can also have these smart contracts that can encode writes, store data, etc. So the applications are really, really endless and really, really fascinating. So that's a story there. Companies like Polymath are doing exactly that, securities tokens on the blockchain. These numbers are a little outdated already, but this number is up to 5,000 with tradable assets on CoinMarketCap. The number of Bitcoin wallets is up to 42 million. And it's just a fascinating time to be in crypto with mass adoption happening. And you have a lot of different use cases sort of being deployed and tested by government agencies as well and international organizations. The World Food Program was able to, use a cryptocurrency and replace their banking relationships. And because of the money they were saving, they were able to feed an additional, in the order of thousands families in a given refugee camp in Jordan. Countries like countries like the United Arab Emirates and cities like Dubai have sort of smart government programs where they're testing these blockchain use cases at a number of their different government agencies. Countries like Georgia, these ex-Soviet satellite state, and places like Japan and Nigeria, they're testing using smart contracts to encode land titles because, the ownership over the land sometimes is not secure and can be easily changed if it's just kept on paper at a government office. Keeping it on the blockchain and encoding it with a smart contract guarantees that the people that own their property will always have the, let's call it paperwork, but digital evidence that they own that property. And probably the most consequential use case is that of identity. We have a data identity crisis in this world right now. And I'm going to tell you why that is. All of your personal information is kept by third-party vendors, and it's owned by those third-party vendors. So for example, Facebook, when you sign up for Facebook, you give them all your personal information. They own that personal information that you have elected to give them. And they use it and they sell advertisements to you via your personal information. They target the ads to you. But they're the ones that are making all that money because they own the data that you have given them. Because they're selling sort of the insights from that data to give you advertising and put content in front of your eyeballs. It gets much worse with other sort of situations. So you could think about education. What happens, all of us have transcripts. Guess who owns those transcripts? And who's the facilitator of those transcripts? Well, it's universities and schools and high schools. What happens if your high school or university ceases to exist? Well, you have a situation where your data goes away too. There's no evidence that you ever completed a degree from that place because that organization is not there. to validate that you have done the work to earn that credential. What smart contracts could enable is the separation of vendors from the data that is being issued. So you can have, at any given time, a university on this blockchain issue a credential, like your bachelor's degree, or a digital representation of your bachelor's degree or your transcript, issue it to you directly, to your wallet on Ethereum. And at that given time, that university was seen to be a legitimate entity, a legitimate vendor of that data, a legitimate vendor of that credential. But let's say 10 years later, a war comes along and the university is destroyed. Well, even though the university is destroyed, at that given point of time when you earned your credential and it was issued to you on Ethereum, there were thousands of computers that validated that that was a legitimate transaction. So your credential now can exist long past the existence of the issuing entity. And so that's a very, very powerful use case that would solve a lot of problems that we have with how we store personal data. You could think of all the incredible use cases and all the issues that we face with respect to personal data now. We have issues, think about, for example, hacks of excuse me, I'm forgetting the name of the organization, but hack of the personal or there's a government organization that maintains security clearances and data about those security clearances. Well, it was hacked and that data was compromised. What if security clearances were issued to individuals through a blockchain, for example? You could think of all of the times that firms like Equifax and the credit reporting agencies have been hacked and exposed social security numbers, credit cards, addresses, personal details. What if that entity was no longer responsible for storing all that personal data in one place? So all of these things are really, really interesting things to think about, and that's why Ethereum is so consequential, because it has opened the door for us to start thinking about new ways to store that personal data and share that personal data. Some practical business applications. This was asked of me when I gave these lectures for the Penn Blockchain Club. So what can you do with something like a blockchain? Well, you can track if there are nefarious sort of actors trying to access certain data on certain devices like drones. So that's a really interesting thing. And in fact, the Department of Homeland Security actually put out a request for a proposal for a solution for that. So you can actually look out for good opportunities with that. Supply chain use cases are supposed to be a very attractive use case. My personal opinion on these things aside, the main consequence of a blockchain in a supply chain is that the data is immutable and it is effectively or essentially perfect. So no data can be misrepresented to any of the parties within the supply chain. And what does that mean? Well, you can actually track where money, for example, if Coca-Cola is selling Coke bottles, well, you can track where the funds went to create that bottle of Coca-Cola, all the way down to the labor that created it. So an organization called Slave Free Trade, they've partnered up, I think actually Walmart and Coca-Cola. I don't remember if they partnered with Slave Free Trade or the State Department, but these are all organizations that are working to use blockchain to eliminate the practice of slave labor in the creation of the products that organizations consume and or people consume, the markets consume. So, it's a very fascinating technology. It's very interesting. There's one thing I wanted to talk about briefly. So we talked about this idea of the hard fork, and I would be remiss if I didn't talk about something called the DAO, specifically the DAO. Specifically the DAO, if we had a conversation about Ethereum without talking about the DAO. So what does smart contracts also enable us to do? They allow us to enter into agreements. That's all well and good. Fine. They also allow us, if we have an aggregate of all these different smart contracts, they allow us to actually create organizations that operate on their own. So one of the early examples of this was called the DAO, the Decentralized Autonomous Organization. And what the DAO did was, it was a series of smart contracts, and it allowed investors to send money to these smart contracts, to the DAO, and then it gave each one of the investors votes. And the investors can vote on the projects that that entity could put that money that they sent to it towards. So it's a very interesting early use case. What ended up happening was, because there was no smart contract code auditing in the early days, a hacker exploited the smart contracts, and it resulted in millions of dollars in those funds that were sent to the smart contracts being siphoned off to that hacker. So as you know from our Bitcoin discussion, all of our transactions are immutable. They can never be reversed. So what would that mean for these investors whose money had been stolen effectively by this hacker? The transactions are permanent. They're there forever on the blockchain. Well, the decision was made by the community to do a hard fork of Ethereum at the block just before the DAO was launched. So what that meant was, this new blockchain, which we now call Ethereum — Ethereum is the new blockchain — has the whole history of the original Ethereum up until when the DAO was released. And all of those people that were involved with the DAO have their funds from the time before the DAO was launched on this new blockchain. Well, what happened to the old blockchain? Well, it's still operating, and it's called Ethereum Classic. And you can see the DAO transactions are still there. So that's just an interesting example of sort of the consequence of this idea of forking, immutability, and all this other very interesting, technology and what's possible. So now this forking has been very controversial. I won't share my input, but nonetheless, it's an interesting conversation to have. So with that, we're ending a little early. It might be because I didn't have questions throughout the program, but and I also cut out a section that I didn't want to talk about just today. But it's good to note that Ethereum is actually going through some software updates. And what that means is that the way Ethereum operates with respect to proof of work and how transactions are settled is actually changing. And it's changing to a different consensus mechanism called proof of stake. And I think, Debbie, that perhaps that is a story for another lecture. So with that, that's Ethereum. The idea here was to give you a little bit of an understanding relative to Bitcoin about how the technology works, and also tell you a little bit about the types of very consequential use cases that you can have with respect to smart contracts. And it's just good to note that, with respect to the two different types of transactions we talked about, the plain value transfer is much easier to trace those Bitcoin sort of transactions and the plain value transactions on Ethereum than it is for the smart contract transactions to be traced, because those smart contracts are changing state. So, different sort of technologies have been used to actually be able to trace those transactions and be able to do data analysis. So with that, that's Ethereum. There's a ton of other blockchains that you can do a lot of research on and learn more about. A good one is Zcash, has some really interesting privacy technologies involved with it. And you could do more research on Ethereum, and perhaps I'll be seeing some decentralized applications developed by some of the people that have seen this seminar before. So thank you, Debbie.